Hi children, we are meeting back again with the part 3 of inverse of a function. We discussed quite a few problems on this topic. You can find those things in the links below if you want, and then we will move on with these new examples. Fx equals x minus 2 whole thing squared minus 1. Here the domain is x less than or equal to 2. So half the x value is taken because we want to make this 1 to 1 in order to get the inverse function, right? Let's look at the graph of this first of all, as usual. Then it's easier for us to imagine. Now look at this. The minimum point of this one is 2 comma minus 1. So 2 comma minus 1, the function is going like this. This side is not there. Why this side is not there? Because of this domain restriction. Let's sketch it and see. Right, this is the sketch of this function. We will look at the inverse function of this, right? We take fx as y and make x the subject here. That is the process of finding the inverse function. You are very well familiar with that now. Look at this. First we take 1 to this side. Y plus 1 is equal to x minus 2 square. Then x minus 2 is equal to plus or minus y plus 1. Now we can't take both, we have to choose either plus or minus here. Let's see what's to be chosen, right? Now if you look at the domain of this original function, it is less than or equal to 2. Therefore the range of the inverse should be less than or equal to 2. Now if you write it like this, x equals 2 plus or minus this one. If you take plus, the range of this will be more than or equal to 2. But it should be less than, therefore we have to discard the positive and go ahead with the negative. Therefore our inverse function of this one will be f inverse x equals 2 minus square root of x plus 1, where x is greater than or equal to minus 1. This is actually this range, right? Now I told you domain and range interchanges in the f inverse. This domain of the original will become the range for this inverse, and this range of the original will become the domain for the inverse, right? We will try to sketch this inverse function now. So what will happen? It will reflect on y equals x line here, right? We will first draw that line y equals x, and then this 3 will go to this, and this will be here. So it will be something like this, right? You will see this, something like this. I think you got the hang of it. We will do few more examples and see. Now this example you can pause the video and try it all by yourself. Then you can realize your level of understanding. If you have not got it properly, you listen to it back again, right? Here the function is fx equals x plus 1 squared plus 1, where x is restricted to be greater than or equal to minus 1. so only one side of the function is there. So we will try to sketch this one now. Minimum point will be 1 comma 1 somewhere here, right? Minus 1 comma 1, sorry, minus 1 comma 1, right? Then it will go like this. Only this side is taken, this side is not taken because of the domain restriction here. And then we will try to look at the inverse function of this. How do you find the inverse? You take this fx as y, then x plus 1 squared plus 1. Then we will make x the subject here. We will take this 1 to this side. Y minus 1 is equal to x plus 1 squared. Then x plus 1 is equal to plus or minus square root of y minus 1, right? And then we have to choose one of these two, right? X is greater than minus 1 here, therefore f inverse x. So then therefore we take the plus. F inverse x is minus 1 plus y minus 1. Why do we take the plus here without taking minus? Because this range of this inverse has to be greater than or equal to minus 1. If you take minus, it will be less than minus 1, right? Therefore we discard minus and take plus. Therefore our f inverse x is equal to minus 1 plus square root of x minus 1, where x is greater than or equal to 1, this range. Okay, now we will try to sketch this. How are we going to sketch this? We can take again y equals x line and reflect this one on this line. So it will go from here like this. I think you got the hang of it very well. We will do another example, right? I'll be doing many examples here. Fx equals x plus 1 squared minus 3. X is greater than or equal to minus 1. Then we can say, we can sketch the graph like this. My minimum point will be minus 1 comma 3. Minimum point is minus 1 comma 3. And then we will try to develop the f inverse function. Y is equal to x plus 1 squared minus 3. Then we will make x the subject. Take this minus 3 to the other side as plus 3. Y plus 3 equals x plus 1 squared. Then x plus 1 is equal to plus or minus root of y plus 3. Now we have to discard one of these two signs. X is greater than or equal to minus 1. Therefore my f inverse x should be greater than or equal to minus 1, right? F inverse x should be greater than or equal to minus 1. Therefore if we happen to take the minus here, it will be less than minus 1. So since we need greater than minus 1, this domain of the original will be the range of this f inverse. Therefore we take the plus here. Therefore our f inverse x is equal to minus 1 plus square root of x plus 3, where x will be greater than or equal to minus 3, which is actually the range of the original function. Now we will try to sketch this. How are we going to sketch this? First of all we draw this y equals x line and then reflect this original on this y equals x line. So this point will come here, and this point will come here, this point will come here. It will go like this. Therefore it is like this, right? Now yet another example. Here x minus 2 squared minus 1 greater than or equal to 2. What will happen here? Only the right hand side of 2 is taken. So we will first sketch this, right? Greater than or equal to 2. This side is not taken. Now here I have directly given you the F inverse. Hereafter I will be discussing few problems where I will not develop the inverse, right? Inverse function. What I would do is I will directly give it like this. Here we are using the positive because this should be greater than 2 because of this, right? Then we will take y equals x line here, and then this is reflected on this like this, right? I think you got the hang of it. We will do another few more examples without developing the inverse function, but directly taking it. Same thing like x minus 2 squared plus 1. Here the minimum point is 2, 1. We will sketch it. Two comma 1 is the minimum point, and it will go like this. This side will not be there, something like this. And then we draw the inverse function is this. We are taking plus here because it should be greater than or equal to 2. Something always added to this 2. Therefore if we take minus, it will be less than or equal to 2, right? Take it, and then we draw the y equals x line, and then reflect this one like this, okay? And then we'll take another example. Fx equals x minus 2 squared plus 1. In this case x is less than or equal to 2, right? We will first sketch this also. X is less than or equal to 2 means this side of the graph is not there, right? Only this side is there. Now we will try to take the inverse function. Inverse will be 2 minus this, because the inverse range should be less than 2 because domain of the original is less than 2. Range of the inverse should be less than 2. Therefore we take the minus here. If we take plus, it will go the other way around. So we take 2 minus square root of x minus 1. This is the inverse of this function. Now we will try to sketch this one. First step number 1 is to draw y equals x line, take this, and then this one will be reflected along this line. Then this point will go here, and it will be something like this, okay? Beautiful, right? Like two hockey sticks kept together. Now look at this. Fx equals x plus 2 squared plus 1, where x is greater than or equal to minus 2. right? This is again a restricted domain, therefore it is 1 to 1. Only this one side of the graph is taken. We will look at the graph. Within when minus 2 plus 1 is the minimum point, and it is going like this, right? So inverse of this will be what? Minus 2 plus, because it should be greater than minus 2. We are taking plus here, not the minus in this place, right? We will take the sketch of inverse. Y equals x line is this, and this will be reflected like this. I think it is very clean and clear for you. Few more examples. Fx equals 1 minus x minus 2 whole thing square, x is less than or equal to 2. Now all this time we discussed minimum graphs. Now this is a maximum graph. Now look at this graph. Maximum point is 2, 1. 2, 1 is here, and then x is less than or equal to 2. That means to this side, this part is not there. Get this? Yeah, this part is not there because of this domain restriction, right? Now we will take 2 minus square root of 1 minus x. X is less than or equal to 1, because this is less than or equal to 1. And then the sketch of this will be a reflection along this line, right? And we'll take this. This is the inverse. Okay. Now we will take more. F inverse fx is equal to 1 minus 1, same thing, x minus 2 squared, but this time the domain is x is greater than or equal to 2. Slight differences. Only difference between the previous one and this one was this was the other way around. But when you look at the picture, see, it is totally different. Now only this side of the function is there. Look at this. This side, right? Now look at this. We will take the inverse function. Now this is 2 plus, because a range of inverse should be greater than 2. Therefore we are taking plus here. This is greater than, therefore we take plus here, right? And then we will take the sketch of this. What we will do, we draw this line, y equals x line, right? And then reflect this one on this. Take this. Understood? Right. Now we discussed actually 15 examples. I am giving you all these things for you to try all by yourself. As in the cases of example, here also only minute differences are there, but you draw all these things and see, it's very beautiful the way they are being changed, right? And please like this video and subscribe my channel, then I can give you very beautiful explanations like this for you to learn the subject clearly and cleanly. Thank you so much.